Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the coolest and most powerful tools in machine learning, the random forest. Now, it might sound super complicated, but I promise you it's built on an idea that you and I use all the time to make big decisions.
Okay, so let me ask you something. When you have to make a really big decision, I'm talking a major one, like where are you going to go on that big vacation you've been saving up for? Do you just go with your gut? Or maybe listen to that one travel blogger you like? Or do you do something else?
I'm willing to bet you ask your friends, right? You ask the friend who's all about relaxing on the beach, the one who's a total foodie, your buddy who loves to hike, and of course, the friend who can sniff out a bargain from a mile away. You get all these different opinions, and the choice you make is way better than any single piece of advice. So, hang on to that idea, the wisdom of a diverse crowd, because that's the absolute key to everything we're about to talk about.
To really get what a random forest is, we have to start with a single tree. So, let's meet the fundamental building block of this whole thing, the lonely decision tree.
A decision tree is actually super simple and logical. You can think of it like a game of 20 questions. It just asks a bunch of if-then questions to get to an answer. Is the price under $1,000? If yes, go this way. Does it have a beach? If no, go that way. It just follows this path down until, boom, it lands on a prediction. It's clean, it's simple, it's easy to follow. But there's a catch.
And yeah, it is a big catch. It's a huge problem called overfitting. This right here is the fatal flaw of our solo decision tree. It's a specialist, for sure, but it can be way too rigid, and it totally messes up when it sees something new.
An overfit tree is just like a student who memorized every single answer from last year's test. They'll ace that test, no problem. But the second you give them a new test with slightly different questions, they completely fall apart. Why? Because they didn't actually learn the concepts, they just memorized the past. Our lonely tree is exactly the same. It gets so hung up on the tiny details of the data it trained on that it's just terrible at making predictions about the future.
So, if our one tree is kind of a flawed genius, how do we fix this overfitting problem? Well, here's the cool part. We don't even try to fix the tree. Instead, we build a team. We build a forest.
And this brings us to this really powerful strategy called ensemble learning. It's just the official name for our wisdom of the crowd idea. Instead of trusting one single flawed model, we combine the predictions from a whole bunch of them. The idea is that the group, the ensemble, will be way more accurate and stable than any single member on its own.
Okay, so how do we actually create this dream team of decision trees? We use a technique called bagging. And yes, that's its real name. It stands for bootstrap aggregating, which is a mouthful, so don't even worry about that part. Just think of it as a super clever way to give each tree a slightly different education.
This whole bagging thing is really just a three-step recipe for diversity. First, you take your main data set. Step 2, you create a bunch of smaller, random samples from it. And here's the key. You sample with replacement. All that means is when you pick a data point, you put it back in so it can be picked again. This makes every sample just a little bit different. And finally, step 3. You train a brand new, unique decision tree on each of those unique samples. Now, each tree has its own slightly different worldview.
Okay, so now we've got a forest full of diverse trees, all with their own unique experiences. But we're not done yet. There is one more ingredient, a kind of secret sauce that gives the random forest its name and its real power.
This is the secret sauce right here. It's not just the data that's randomized. The questions the trees are allowed to ask are randomized too. So imagine a tree is trying to make a decision, and it has, say, 10 possible questions it could ask. Instead of letting it pick the absolute best question out of all 10, we force it to pick the best question from a random little group of maybe only 3. This is what makes the trees truly independent thinkers.
And this is why that little trick is so brilliant. Let's go back to planning our vacation. Without this rule, maybe every single one of your friends would focus on the weather, because it's the most obvious thing. But by forcing randomness, by telling one friend, hey, you can't consider the weather, just focus on food and activities, and another, you only get to think about budget and travel time, you force them to explore other angles. This stops all the trees from just copying each other and guarantees you get a much richer, more well-rounded set of opinions.
All right, so our forest is built. It's diverse, it's random, and it's ready to go. We have all these different opinions from all these trees. So how do we actually combine them to get one single confident prediction?
Well, it's actually super democratic. If it's a classification problem, something like, is this email spam or not spam, every single tree in the forest gets one vote. The final answer is just the one that gets the most votes. Easy.
If it's a regression problem, like what's the price of this house going to be, each tree gives its own estimate, and the final answer is simply the average of all of them.
So just look at this. Say we ask our forest of 100 trees a simple yes or no question. If 75 of them vote yes and only 25 vote no, well, the group's decision is pretty clear, right? It's yes. This is that wisdom of the crowd in action, turning a whole bunch of simple votes into one really confident final answer.
So this brings us to the big why. We've seen how it's built, we've seen how it makes a choice. But let's just pull it all together and talk about why this method is so darn effective, and why data scientists love it so much.
I'm not kidding. The random forest basically has superpowers. Because it averages out all the little mistakes and biases of the individual trees, it's known for being extremely accurate. And it's super robust. It crushes that overfitting problem we were so worried about. Plus, it's a total workhorse. It's versatile enough for all sorts of problems. It's great at handling messy, real-world data that might have missing pieces, and it can even tell you which factors were the most important for making its decision. It's the whole package.
So when you boil it all down, the takeaway is simple, but it's so powerful. Whether we're talking about a fancy machine learning algorithm or just planning a vacation with friends, the principle is the same. A committee of diverse, independent thinkers is almost always smarter and more reliable than any single biased expert. By bringing a crowd together, you cancel out the noise and you're left with a much clearer signal. And that kind of leaves us with this one last big question to think about. As we keep trying to build smarter and smarter AI, maybe the answer isn't to build one single gigantic all-knowing superbrain. Maybe the better, stronger, and more reliable path forward is to grow a wise forest of many simple minds all working together. Thanks so much for joining me.